going on, everybody? So, Unit 11, Lesson 5, Page 2. Some of you guys may recognize that I uploaded a bunch of lessons again. iTunes spazzed out yesterday, and it deleted all of the lessons in Unit 11, at least on my end. I don't know if it deleted it on your guys' end as well. So I had to re-upload lessons 1 through 5 for the people that need to still go back and watch it on YouTube. If you already did the lessons, obviously you don't have to re-download them. I just want to make sure you guys are aware of that if you saw a bunch of them pop up again. I think the issue is fixed now. It only did it to Unit 11 lessons. I'm actually clicking in right now just to be safe that everybody can download everything from 5. Yeah, everything is back in there. I still have no idea why it deleted. They just disappeared. Whatever, I guess. Anyways, so that being said, same lesson as yesterday. We're going to do a little bit more with it today. We're going to talk something with degrees, and we're going to talk something with radians. Okay? So, I am going to use the calculator a little bit more today. Calculator is not always going to be allowed. So it depends how the question's asked. So like everything that we did on the front page, we were not allowed to use the calculator. And the reason why is because those answers are going to be in radical form, so it has to stay in radical form. If you try to change an irrational number into a decimal, we know that irrational numbers go on forever and they're non-repeating. So we're not allowed to use that as a final solution. So that being said, I'm going to go down to exercise number 4. I'm going to walk through, it says in each of the following, an angle is the reference have been given. Using your calculator, make sure it's in degree mode, determine the sine and cosine of both the angles and its reference angle. So, I'm not going to find the reference angles. I'm just going to focus on the sine and cosine because I want to talk about something first, and then we're going to go down and do some radian stuff. So, what this question is asking us to do is it wants us to find the sine and the cosine of this angle. So we can do this by hand. And if we do it by hand, that's by graphing the rotation. And actually, I will do it for the first one, but I'm not going to do it for the next two. So it's asking us to graph the rotation, and it's asking us to find both of those solutions, the sine and the cosine. So the first thing I'm going to do is graph the 110. And 110 degrees is going to fall into the second quadrant. So we know this is 110. I drew it a little bit closer to the y-axis because that's 90 degrees. And then I told you guys that we had to create a right angle. So the issue with this problem is I drew this right triangle. You're okay, Shane. You didn't miss much. I just started. This is all I've written down so far. So we're on the second page of lesson number 5. So that's 110 degrees. The issue with this question, though, is the angle on the inside, if we subtract that from 180, is going to be 70 degrees. So everything we've been doing up to this point has been a special right triangle. This one is not a special right triangle. It's not a 30, 60, 90. It's not a 45, 45, 90. So the only way that we can solve this as of right now is with the use of a calculator. There is a way that you guys can do it algebraically. It's no longer done in Algebra 2. It's something that you could possibly see. Actually, you definitely see it if you go on and take pre-calculus next year. It's called Law of Sines and Law of Cosines. It is not something I will be showing you guys this year, though, especially online. It's not an internet lesson that you would want to do. But yeah, Math 12 and pre-calc will be doing Law of Sines and Cosines next year. As far as this year goes, we're just going to do it on the calculator. So if you open up your calculator on your app, or if you got a handheld calculator at home, you can use that. I'm going to walk through the same step that I showed you guys yesterday on the calculator. Make sure that you hit mode first. So you have to hit the mode button that's right next to the second button. And you have to make sure that your calculator is in degree mode because it was given as 110 degrees. So I'm just going to go down. I'm going to click on degree. It's already clicked. And I'm talking about down here. You guys should be able to see me flicker in between radian and degree. I'm on degree mode. Done. Now I can just type into my calculator sine of 110 parenthesis. Enter. As you guys can see, this answer does not come out pretty. And the reason why it's not coming out pretty is, for one, it tells us round all answers to the nearest hundredth. So it's telling you it's not going to come out to be pretty. That, and because this triangle didn't work out nicely, because this triangle didn't work out nicely, why does it keep freezing on me? It's not going to be a special right triangle. So it's not going to have that whole number of 1. It's going to be that crazy angle, and this is an irrational number. We just can't figure it out at this point. So we're just going to round it to the nearest hundred, and we're going to say that sine of 110 is 0.934. Or I'm sorry, 0.94, because we're rounding to the nearest hundredth. And then we're going to do the same thing for cosine. So if we do the cosine of 110, am I definitely on? Yeah, okay. And that's going to be negative 0.34. I just realized what I did. This is why it's working out weird. So I just wrote this all down. We're supposed to be finding the angle of the reference angle. I just found the outside angle. Remember when we were doing the problems on this other page? We were doing the angle on the inside. If you guys look at what I just did, and this is a dumb mistake by my part since we've been doing it the correct way for the last 4 lessons, I did the angle that was on the outside. I'm not supposed to be typing the angle of the one on the outside into the calculator. I'm supposed to be typing the angle on the inside. So, my bad. The thing that I got to fix right now is I didn't want to type in 110 into the calculator. I wanted to type in the reference angle. I wanted to type in the 70 degrees. That was my bad. I completely overlooked that. That is what we're trying to find, because we're trying to find the inside triangle. So I'm going to redo that real quick. I got sine of 70 degrees, which is going to be, oh, does it still come out to be 0.94? Why is that happening? That's very interesting, isn't it? Wink, wink. And that's still 0.34. The only difference is this time it didn't say it was negative. So I'm going to write all that down. So I had sine of 110, and I also had cosine of 110. And we're noticing now that these answers are kind of similar. The calculator said it was negative 0.34 for 110, but it still said it was 0.94 for the sine of 110. This is really weird that it's happening this way. So if you guys haven't caught the drift, I didn't really make a mistake. I'm trying to have you guys see what's going on with the part that says, what do you notice about these solutions? These solutions are looking very, very similar. Okay, so I'm going to try this again. I'm going to try it for part B. Yeah, technically I needed to make the mistake, Ella. Because what I want you guys to recognize, and I got to point out, if you guys are watching these videos, some of you guys did this on one of your homeworks. Some of you guys did this on your homework, what I'm showing right now, before I even taught it. So it's kind of fishy. So if you learned how to do this at some other point in time, I don't know when that would have been. But yeah, I saw a lot of people on homework number 3 solve it similar to what I'm doing right now. If you are one of those people, I'm guessing you probably look some stuff up on the internet rather than watching my videos, which is fine. Just respond to my email that I sent you if you did it this way, because I'm just wondering where you got it from. Because when we start getting into crazy angles, they don't work as nice. So I just want to make sure that you guys know how to graph them still. So if I go to do the next one, I got 235. 235 is going to be down here in the third quadrant. So that was 235. And we also need to find the reference angle. I am a great actor. I feel like I could have been an actor if I really chose to do so. So I got to find that missing angle right there. The only way we can find that little angle there is if we do 235 minus 180, because remember that flat line is going to be 180. And 235 minus 180 is going to be 55. So what I'm going to do is I'm going to find the sine of 235. I'm also going to find the sine of 55. But I'm also going to do the cosines. And you guys may be able to predict these answers based on what we did on the first one. Maybe you might not, and that's okay. But I'm trying to show you guys that there's a pattern. Oh no, if notability crashed, that means everything I just wrote down for that second question disappeared. Oh, that don't work. Not everything. Okay, that's not awful. I don't have a lot to rewrite. Chad still has not gotten back to me. He is slacking. So I got sine of 235. I said sine of 55. And then we have cosine of 235 and cosine of 55. So I want you to look at those answers on the left. Notice what happened with our sines. Those numbers stayed the same. Same thing happened with the cosines. Those numbers stayed the same. And I shouldn't say they stayed exactly the same. They changed a little bit, and we're going to talk about why they changed. But I want you guys to see that these angles are very, very similar to each other. So I'm going to come over here, and I'm going to tell you guys that I believe that these sines are going to be the same or very similar to each other when we type them in the calculator. So my calculator disappeared. So if I type in sine of 235, where is it? That comes out to be negative 0.81. Now, I think 0.81 or 0.82, if we round it to the nearest hundredth, is going to be very similar to that. But I know by looking at this, it's going to be positive before I even type it in. And maybe you guys are recognizing what's happening and why it's going to become positive. Maybe some of you guys will not. But yes, I'm right. That does come out to be positive. Now the question is, why is it doing that? So we said that this was a negative 0.82. And this is a 0.82. The reason why the sign is changing is based on the quadrant those angles would be if you were to graph them. So if I had 55 degrees, 55 degrees would normally be graphed in the first quadrant. 235 degrees is normally graphed in the third quadrant. So if you think about what we talked about the other day with that add sugar to coffee, when we were talking about the sines, add sugar to coffee, in the first quadrant, the sine value is positive because the sine value is y. In the third quadrant, the sine value is negative. Only tangent is going to be positive down there. So this goes along with what we talked about the other day when we're talking about positive and negative values. So these angles, though they are not completely equal to each other because the signs are off, these are called complementary angles. And you guys may have learned about complementary angles back in geometry. Complementary angles when you guys were doing parallel lines It's very, very similar to it, but it's not exact. It's just saying that they're going to create the same reference angle. That's why we're allowed to call them complementary, because they have complementary, and I'll write that, I'll put reference in front. They're complementary reference angles. So that's why the values are going to be very similar to each other. So fortunately, again, I keep saying this, when it comes to the Regents exam, this would be a popular multiple choice question. You guys don't really have to worry about it, because obviously I'm not going to be throwing a lot of multiple choice questions at you within the next month. But that's for the people that choose to take the Regents exam in their future. If you do plan on taking it, then yeah, that's going to probably be a question you see. Okay. Same thing's going to happen with these ones. So if I type in the cosine of 235, well, 235 is normally in the third quadrant, like we wrote. And if I'm looking at my graph, cosine, if it's down here in the third, that means it's going to be negative. And that's what's popping up on my calculator. It says it's negative 0.57. Well, now I don't even have to type cosine of 55 into the calculator, because I know 55 degrees is in the first quadrant. So we know that the answer is going to be exactly the same. We just have to determine, is it positive or if it's negative. Well, if cosine of 55 or 55 degrees is in the first quadrant, then we know it's going to be a positive value. Okay? So it's just asking, what do you notice about these solutions? That's what I wrote up top. They're complementary reference angles. And it just means that the angles are going to be, or I'm sorry, the values are going to be the same, because the angles are the same reference angles. They're the same number in both spots. It's just in a different quadrant. So I don't foresee a lot of you guys solving it that way. I just want you guys to recognize that a lot of times when you do angles, the answers are going to come out to be identical to each other. It does happen a lot. So if you see answers repeating on homeworks or in the future when we're graphing some stuff, it's okay. It's okay if something repeats. That's what I'm just trying to get at here. Okay? It will make more sense when we actually graph a sine curve and we graph a cosine curve on an x and y axis. Right now, we're just graphing a unit circle. But once I show the next part, I think it will be coming, you guys will be able to picture it a little bit better. Last thing I'm going to do with you guys today. So these 3 questions, these are all in radian mode. So I'm going to do one all out by hand. I'm going to show you guys how to do it by hand. I'm also going to show you guys that this can be done on the calculator. Most of the time when you guys do these with the calculator, though, it's kind of like yesterday. You could do it on the calculator, but it's more as a check, because sometimes you're going to get a crazy decimal and you have to write it out as a exact value. You would have to write it out as a fraction. So I'm going to do part A all algebraically. So, and I put down, evaluate each of the following trig expressions, but make sure to convert to degrees first. So this is going back to the lesson, this would have been on Thursday. So on on Wednesday when we did conversions. So in order to convert something from radians into degrees, we multiplied it by 180 over pi. So what I'm looking to do is I'm doing that cross reducing that we did the last week. So I noticed that I have pi's across from each other. So those pi's can cancel out, because pi divided by pi is really just 1. I also have 180 and 2, and I can divide both of those by 2. And we're going to notice that this is going to be 90, and that's really just going to be 1. So we're just going to be left with 90 over 1. So essentially, if we change this into degrees, all of that is going to cancel out to be sine of 90 degrees. Now this is much, much easier to graph by hand because we can put it on an X and Y axis and draw the rotation just like we did on the previous problems. So that's what I'm going to do. So again, I'm doing this the long way, but I'm going to show you guys this can really be done on the calculator. I have my initial ray. My ending ray is 90 degrees, so it's going to just be a vertical line. So this is our 90 degree. This is not a special right triangle. This is not 30, 60, 90. It's not 45, 45, 90. What we're actually looking for is the coordinate up there. And you guys may recall in one of the lessons last week, I told you guys when we're working with a unit circle, all I have to know is unit circle is always 1 unit. So I need to know what is the coordinate to get there. Well, my x value is going to be 0 because I didn't move sideways to get to this point. I just went up. And because it's a unit circle, it's 1. Now this question is saying find the sine of 90. Well, sine we said is the y value. So if you look at those two coordinates, or those two numbers we wrote down in our coordinate, the y value is 1. So sine of 90 is going to be 1. So again, I told you guys there's a check for this. There's a lot of steps that went into that play. We had to convert it, we had to graph it, we had to find the coordinate, and then we had to find the y value of that coordinate. So now I'm going to show you guys the shortcut. And this is, again, it's more of a check. If it's a multiple choice question, you can do this, but most of the time it's going to be a short answer. So you're going to have to show the work when it comes to these, but it's a check to make sure that you guys are right. So I can start off. I know my calculator is already in degree mode because I set it up that way earlier. So I'm just going to type in sine of 90, and the answer should come up to be 1, which it does. So I know my answer is right based on what I had there. But what I want to do is check to see if my original answer, the pi over 2, because that's what we started with. If I type that in and press enter, the answer is not coming out to be 1. And the reason why is because our calculator is in degree mode. So again, you guys have never, ever done this switch before. Everything in the past in algebra and in geometry, we as the math teachers have always set the calculator into degree mode for you. This year, now that we have radians, I'm going to teach you guys that little switch. You can press the mode button, and if you started off the problem in radians, you just have to make sure that the angle is in radians first. Now that I just switched it back to radian mode, I can type this same exact problem in, and it's going to say the answer is 1. So it doesn't always come out to be like a nice number like this one was. I definitely started off letter A with an easier problem. Like if I go to do the next one, it says sine of pi over 3. So I'm going to do that same exact problem again, but I'm going to change it to a 3 and press enter. And you guys are going to notice this one didn't come out to be nice. So this one you would have to show the work to find the exact form. We have to find the exact fraction. Okay? So I'm just going to do one more, show you guys that it does relate to each other, and then I'm going to call it for today. So if you guys look at part B, I have to do the conversion first. In order to do the conversion, I'm multiplying it by 180 over pi. The pi's are going to cancel out. And then 180 divided by 3 is really just going to be 60 degrees. So I'm just cross-canceling. So really, I have sine of 60. So I'm going to graph it out. It's just like we did before. Nothing is different here. 60 degrees is going to be over here in the first quadrant. This time, you guys can create a right triangle, though. And my right triangle has the 60 degrees over by the origin there. And now we know it's a 30, 60, 90. So this is a special right triangle. We can do the same stuff that we did, that we've been doing for the last week. We can use the 1/2, the radical 3 over 2, and the hypotenuse is always 1. Well, sine, once again, is the y value. Well, the y value in this case is the radical 3 over 2 because the y value always is the vertical line. It's what's going up and down. So since that is our y value, we know that our answer is radical 3 over 2. And now I can type that into the calculator. I'm just going to type in radical 3 over 2, and I'm going to see if it comes out to be that 0.866. And it does. So this is a check. By being able to convert our calculator into radian mode, we can check right from the beginning. We basically already know the answer before we even start solving the problem. And I know in math that's going to be beneficial for a lot of you guys. If you already know the answer and you solve it through and your answer checks, then you know you did it right. So just use that to your advantage when it comes to this homework for homework number 5. So I'll pull it up again. So like in number 2, you guys will be able to check that with your calculator because it is in radians. I still suggest putting it into degrees first because it'll be easier to solve that way. But it's just an option out there for you. Okay? So if you guys have any questions with these, let me know. I did say this yesterday. I'm going to write it down. Number 4, use the cos theta squared plus sine theta squared equals 1. Use the Pythagorean theorem in order to solve it. It'll make life a little bit easier for you. This homework is set for Thursday, which is, I don't even know what today. Today's Tuesday. So yeah, the due date will be on Thursday. Due dates will always be on Thursdays and Mondays. So homework number 5 will be Thursday. Homework number 6 will be on Monday next week. Okay. Yes, Zoom will be tomorrow. Sorry about today. My father-in-law had to go to the doctor's, and he just had he had to get some shots in his back. But because he got those put in, he wasn't allowed to drive. It kind of made him a little woozy and stuff. So I had to take him to his doctor's appointment. So I got to sit in a parking lot for about 2 hours. It was a lot of fun. But, all right. Well, yeah, so if you guys want to stop by Zoom for any questions, feel free to do so. Yeah, feel free to do so, Sierra. If anybody else wants to stop by, you're more than welcome to. Feel free to email if you guys prefer doing that. But yeah, that's all I got. So I hope to talk to you guys soon. Have a good one, guys.